Hello guys, welcome back to our YouTube channel, and today we are going to discuss the second problem from the LeetCode contest 411. Okay, so let us see the question. So the question is nothing but you are given two arrays, okay, and you are given an integer in value. So the first array is nothing but an energy drink A, and second array is nothing but energy drink B. Okay, let us see. These arrays represent the energy boost per hour. Okay, so here n is nothing but you have n hours. Okay, so the overall goal is you want to maximize your total energy boost by drinking one energy drink per hour. However, there is a condition here. However, if you want to switch from consuming one energy drink to another, you need to wait for 1 hour. You need to wait for 1 hour. Okay, so meaning you won't be getting any energy drink on the next hour. Okay, so in this way you want to return the maximum total energy you can gain in the next n hours. Okay, so note that again there is one more note. You can start consuming any energy drink. Okay, so here with this example you will understand the question entirely. Okay, so you have energy drink A, which is 1 3 1, and energy drink B we have 3 1 and 1, right? So the question is you can have any energy drink from any container. Okay, this is A container, this is B container. Okay, so what will I do? Is I will have this energy drink which is 1. I will have this energy drink and I will move forward. Okay, now here I can have this energy drink which is 3, and I will move forward and I will have this energy drink which is 1. What is the total sum that we got? Which is 5, right? And what is the output? Our output is 5, right? So you may not have understood the question entirely, but from this second example you will understand it. So the second test case is 4 1 1, and here we have 1 1 3, right? So here if you see, what will I do? I will only drink the energy drinks from the container A. So I will get 4 plus 1 plus 1. So what is the answer? 6. Or I can consume only energy drinks from the container B. I will be getting 1 plus 1 plus 3 is nothing but 5. Can I simply return the maximum of these two values, 6 and 5? No, you cannot, because here in the question he mentioned that you can switch from one energy container to the another energy container. Okay, so what does that mean? If you see here, what I will do is I will have this energy drink which is 4. Okay, now I will move to the next container which is B. But if you see, if you switch from a X container to Y, you cannot have that energy drink for that hour. Okay, for that hour you cannot have any energy drink. So here I cannot have any energy drink. Now I will simply consume this energy drink which gives me an energy of 3. So what is the sum? 7. 7 is greater than 6 and 5. So for this test case my answer is simply nothing but 7. Okay, so this is the overall question, guys. You are given two energy drinks, energy A and energy B. So you can consume, let's say you are consuming this energy drink and now you want to consume another energy drink from the different container, then you have to switch. But if you switch, you cannot have energy drink for the next hour. Okay, but after that hour you can have the energy drink which is 1. Okay, so in this way you have to return the maximum energy that you can gain from these energy drinks. Okay, so what do you think? That the concept that we are going to use here? Are we going to use tags, queues? What do you think? So just a second. If you see here, This is simply nothing but index 0, index 1, index 2, right? And you have given two arrays of same length which has energy powers. So at each index, what can you do? What can you do? You can consume, let's say you are at A of I, okay, energy drink A. You can consume this energy drink A and don't switch to the next container. Just have the drink from the same container, which is A to A plus 1, or B of I to B of I plus 1. You can have the energy drinks from the same container itself. You can do this one thing, or if you are taking an energy drink from the container A and now you want to switch to the next container, which is B of I plus 1. So this is another way that you can do. Or you can have the energy drink from B of I and switch to A of I plus 1 by not having that A of I plus 1 drink. So what is the difference here? Here no switch is not happened, and here switch is happening, like you are switching between the containers. Okay, so these are the two possible moves that you can do from any index. So what do you think that our logic or our solution is going to be? So here let's assume that I am starting to take the energy drink from the container A. This is A container and this is B container. I am starting to take the energy drink from the container A. So my answer will be 4, and again I will take the energy drink from the container A itself. 4 plus 1 plus 1, which is 6. Okay, I went like this. Now what will I do? I will take the energy drink from the container A and I will take the energy drink from the container A, and now I will move to the container B, which is 4 plus 1 plus 3. But if you see here, if you move from any container to another container, you cannot have that energy drink on the so and so container, so and so hover, right? Which means you cannot have the energy drink here. So your answer is 5, right? Okay. Is there any other way that I can do? Okay, I can do something like this. I will take this energy drink 4 and I will move to the container B. If you move, you cannot have any energy drink at that hour. So it will be 0. Now I will have energy drink which is 3. Like total it will be 7. Okay, is this all? No, right? Because in the question he mentioned that you can start consuming any energy drink in the beginning. Here I have started by taking the energy drink 4, but it is not the only way. You can also start by taking the energy drink from the container B. If you start taking that from the container B, you will get something like this: 1 plus 1 plus 3, it will be 5. Or I can do something like this: I will have this, and I will go to the container A. 1 plus 1 plus 0, because you cannot have this energy drink, so it is nothing but 2, right? Or I can have this, I will move to container A, I cannot have this, and then I will have the next drink which is 1, so it will be 1 plus 1 again, which will be 2. So what did I do here? To put it simple, can I say that I have tried all the possible? So can I simply say that I have tried all the possible ways from each index? From the ith index, I did this thing, which is I will consider the same energy drink from the same container, or I will simply switch. Did I do this from the each index? So if I want to try each and every possible way, then what concept am I talking about here? Can I simply say we can use recursion here? Yes or no? So let us see how we are going to use recursion. We are going to write a code where we will try all the possible ways. Okay, from each index we will have the energy drink from the same container. as well as you will have the energy drink from the different container. We will write the code for both of these, but among all the results that we have generated, which one will you return? Obviously, you are going to return the one which has the maximum energy that you have gained, which is in our case is 7. Okay, now let us write the code for recursion. Okay, so here is the question. So let us try to write the recursive code for this. Let me make it full screen, and so here I have told you that you can start taking the energy drinks from the container A or from the container B, right? We can start taking in any one of the container. So what I will do is I will declare a variable. Since it is expecting a long int, let me declare long a. Okay, so let me define a function which is called as solve. We are going to discuss what this function is going to do. Okay, and I will pass few parameters, 0 and 0. I will explain why, and this as 0 as 1. Okay, and this is b. So I will simply return the maximum value that I got among these two values. One is if I start taking the energy drinks from the container A, and if I start taking the energy drinks from the container B, which one is giving me the, or which, by considering from which initial start is giving me the maximum energy drinks, I'm simply gonna return that. Okay, and let us write the solve function here. Okay, so the solve function is of long return type, and this is a parameter for that, and energy drinks B, and the third parameter is nothing but index. Whenever you write any recursive code, and if you don't want to use for loops in it, then you have to use index as a parameter. Okay, and the second one is type or current drink type. So the second one indicates from which container are you taking the energy drinks. 0 indicates from the container A, and 1 indicates from the container B. Okay, so I want to take a energy drink from the container B or from the container A. This parameter defines that. Okay, now let us write the code. The first one is I want to take this index drink. I want to take the IDX drink. Okay, so I will declare a variable drink is equal to. Now I will simply check current drink type. Oh, let me put it as container. Okay, container is equal to 0. If it is equal to 0, what does that mean? Take the energy drink from the container A. Okay, so and let me change this to simply A, and this is simply B. Okay, so something like this, array of IDX else B of IDX. Okay, if the container is equal to 0, then take the energy drink from the container A or else from the container B. Done. So now you have taken the energy drink. What you should do? Since you have taken the first drink, now we have two options. Okay, either to take the second drink from the same container or take the second drink from the different container. So if you take the same drink from the same container, will there be any switch happening? No, right? So for that, I will declare a variable no switch. No switch is equal to drink, the drink that you have taken just now, plus call this function solve A, B remains the same, index is nothing but plus 1, and the container, what should be the container B? Container will be the same, which is container, because we want to take the energy drink from the same container, right? Now what do you think the line of code will be for switch? For switch, you will take the drink, right? And then what you will do? You will call the function, right? These two parameters are going to be the same. Is it here? We will pass the index, and here we are going to simply pass 1 minus container, because we don't want the energy drink to be taken from the same container. We want the energy drink to be taken from the different container. Now tell me, is this correct? Is it index plus 1 or index plus 2? See, once you go from this container to different container, you cannot have this drink, right? So do I need to simply put idx plus 1? If you are not taking any energy from the next container, is it required for us to put idx plus 1? I can simply place idx plus 2, right? Yes. And here I got the results. One is by taking the switch and one is by not taking the switch. I am simply going to return which one gives me the maximum gains. Okay. So we are missing one thing, which is, what is that? The base condition. So if index is greater than or equal to the error size, then simply return 0. That's it. Run the code. Okay, just a second. It is showing accepted. Let us run the code. It will not get submitted, right? We will get TLE, because if you see here, the constraints n is 10 to the power of 5. So we can clearly see we will get TLE because you are using recursion here. So how do we optimize this? How do we optimize? So which concept can we use here to optimize the recursive codes? Exactly. We can use dynamic programming, right? So how dynamic programming can be used here? Exactly. We all know we can simply use memoization, right? So how do we apply memoization here? So first, in order to apply memoization, we need the data structure, right? Here, what is the data structure is going to be? Can we simply declare a vector int? No, right? Because we cannot simply use a vector int, because we have two states here. Okay, one is energy state A and one is energy state B, right? So what is it going to be? Exactly a matrix of 2 rows and n columns. Okay, so we are going to simply declare that vector of vector, and this is going to be long dp of 2 of vector of long. Let me pass the size, and we will initialize all the values to -1. Okay, so what is the first step that we need to do here? First step is simply check if, but we need to pass the dp as a parameter, right? dp here, dp here, and here we are going to simply do vector long plus of dp and then index. So what is the first thing that we need to do? Since there will be multiple recursive calls, there will be overlapping subproblems, right? As we all know. So first you need to check, did I solve this overlapping subproblem or not? Do I have the result of this overlapping subproblem or not? If I have, then I will simply use it, right? So how do you check that? You can simply do dp of current drink type is container of idx is not equal to -1. If it is not equal to -1, what does that indicate? That you have inserted some other value. So I am gonna simply return dp of container of idx. Okay, but we also need to store this value, right? So instead of returning, I will return dp of container of idx is equal to maximum of these two values. Let me run the code. Okay, I have got some errors. Yep, we are taking dp, right? So we need to pass dp as parameter. So our code got accepted, but still in dynamic programming, first thing that we will do is recursion. Second thing that we will try to optimize is by using memoization, and third one is tabulation, right? Can we use tabulation here? If yes, how are we going to use tabulation? Let us discuss that by writing the code. Okay, so we can use tabulation simply like this. First you need to get the size, which is this energy drink a dot size. Okay, and now you are going to declare a vector of long. So here, since there are two ways, so here if you see here the highlighted part, this is 1 2 3, all these three possible ways are starting if and only if I start with container A, right? And the remaining these three are from the if I start with container B, which means there are two states that I need to maintain, right? So for that I will declare a dp A of size n,0, sorry, n,0, and then dp B of size n,0. So I have two arrays, dpa if I start with dp, like if I start with container A, and dpb if I start with container B, right? So we have declared the two states. Now what is the next step? So if you see here, no matter what, no matter which energy drink you start with, you will start with the first drink, right? If you start with dpa, then you will have this energy drink. If you start from dpb, you will have this drink, right? So can I simply say that dpa of 0 is nothing but energy drink a of 0, and the same thing for dpb of 0 is equal to energy drink b of 0? Yes or no? Yes. Now what is the next step? Now you need to calculate the answer for other states. So dp a of I is equal to, so here you have two possible ways, right, that we have discussed. Either you stay in the same container and have the same energy drink, or you make the switch. So let us write the code for the first one. So if I stay in the same container, what will the code look like? How will the code look like? So it will be simply dp of I minus 1 plus the previous energy drink we had plus the current energy drink, which is energy drink A of I. So this is one thing that you can do, right? So this is only for if you stay in the same container. But let's say if you want to go from container A to container B, then how will the code look like? So first thing is, it will be something like dpb of I minus 1. Till now, whatever energy drinks we had from the container B plus the current energy drink from the container A. So this is if we have stayed in the container A. Sorry, this one. The first one is if you stayed in the container A only. And this one is you are coming from the container B to the container A. Okay, if you are coming from the container B to the container A, let it put a simple. So we have two arrays. This is container A and this is container B. You are having this energy drink, right? And when you move to the next index, here you have two possible ways. Either you are coming from the previous index of the same container, or you are coming from the previous index of the different container, right? So first one is nothing but you are coming from the same index from the same container. different index, same container. Whereas here you are coming from the container B, right? And you are having the energy drink A of I. But can you have the energy drink A of I when you are coming from the container B? No, you cannot, right? So in that case, you are gonna simply exhaust the previous value, which is you cannot have the last drink that you had. And the same thing goes for the container B as well. Just few changes. This is going to be B. Now if you see, for every index we have two ways. One is take the energy drink from the same container, take the energy drink from the different container. So which one will you consider? So if you see here, to put it simple, okay, to put it simple, let's call this as X. Okay, so X is nothing but you stayed in the same container but from the different index, which means nothing but you had this previous drink. So let us entire thing called as Z. Okay, let's say one more thing is Y. So you are coming from the different container, from container B to container A, and you are having a value of Y. So let us call this thing as some D. So among these two ways, which one will you consider? The one which gives you the maximum value, right? Staying in the same container and having the different energy drink, comma, coming from a different container and having this energy drink, which one will give you the maximum value? That one you will consider. Yes or no? Right. So here it is going to be simply maximum of this, comma that, and here also it is going to be maximum of this, comma that, and now which one will you return? So can I simply say that I will return dpa of n-1? No, you cannot, because you don't know from which container you started, right? From each index you are trying for different possible ways on both the containers. So that is why you will check dpa of n-1, dpb of n-1. Which one is giving you the maximum value, that one you will simply return. Okay, so let me run the code. So here I am getting accepted. Okay, our code got submitted, guys. And if you like the video, do hit that like, share and subscribe button, and follow Smart Interviews for more content. See you in the next video.